Hi, my name is Muhammad Nabi Asfar bin Mat Najib, and my student ID is 2023454914. Today, I will explain about the introduction to ground anchor construction. Ground anchor are structural elements used to support retaining walls, slopes, and excavation by transferring loads from the structure deep into the ground. They consist of steel tendon inserted into drill hole and bonded with grout. Once tensioned, this anchor helps prevent soil movement and ensures stability. This method is widely used in both temporary and permanent construction projects due to its effectiveness in space-limited areas. For stabilizing retaining walls, ground anchors are frequently used to reinforce retaining walls, preventing them from overturning or sliding due to soil pressure. For preventing uplift, ground anchors can be used to counteract uplift force, such as those caused by hydrostatic pressure or buoyancy. For slope stabilization, they can be installed in slope to prevent landslide and ground movement, particularly in areas with steep or unstable soil. For temporary support, they can provide temporary support during construction, such as in excavation or when constructing coffer dams. For the last, soil improvement, in some cases, ground anchors can be used to improve the stability of the soil itself, increasing its load-bearing capacity.
Assalamualaikum. My name is Aris Daniel Mehmet Faizal and my student number is 2023678562. Okay, first of all, I want to thank Nabil for a brief explanation about introduction and function of ground anchor. Today, I will talk about installation process for ground anchor construction. As you can see, we have 8 installation process. First of all, we have drilling the anchor bar hole. The first step involves drilling the bar hole to the required depth and inclination using a high power rotary drilling rig. The alignment and position of each bar hole are set according to engineering drawing to ensure effective force transfer to the ground. The hole must penetrate through soil and into the stable layer of rock or dense material, which provide anchorage for the bond zone. This process is carefully controlled to maintain position and avoid deviation that could affect anchor performance. For a second installation process, we have installing the tendon assembly. Once the drilling is complete, a pre-assembled tendon unit is lowered into the bar hole. This tendon typically consists of high-strength steel strand or bar. The lower part of the tendon, known as the bonded zone, is where the load will be transferred into the ground. It is usually bare or rubbed to enhance bond with the grout. The upper part, known as the unbonded length, is covered with a plastic sheet to prevent bonding with the grout, allowing for the free elongation during tensioning. Centralizer are installed along the tendon to ensure it stays centered within the bar hole. Next, we have grouting and bond formation. Grouting follows immediately after tendon placement. A cement-based grout is pumped from the bottom of the bar hole upward into the trimming method or grout tube. This technique ensures that no air pockets are left inside the bar hole and that the grout fills all void, particularly in the bonded zone. In rock formation, the grout may penetrate, fracture, and form an enlarged grout bulb, increasing the effective anchorage area. The grouting process is monitored closely to control pressure, volume, and flow rate. For my last part, we have curing of grout. After the grout is injected to the soil, it must be allowed to cure properly. The curing period ensures that the cement achieves sufficient strength to develop a strong bond between the tendon and the surrounding ground. This period may vary depending on the grout mix design and environmental condition. Adequate curing is essential to ensure the stability and load carrying capacity of the anchor. Okay, I will pass the next installation process to my group mate Alif Aiman. Thank you.
Assalamualaikum and a very good day to everyone. My name is Alif Aiman bin Bakhtiar and I am from class 4M. Today I will be presenting about the construction processes related to anchor systems, particularly focusing on the stages after grouting from anchor head installation to final finishing. Let's begin. First, let's look at the installation of the anchor head and tensioning process. After the grout has cured properly, we begin installation the anchor head assembly. This includes a bearing plate, an anchor head block, and a wedges system. Next, a hydraulic jet is used to pull the tendon to a predetermined load, usually about 110% of the working load. Once the desired load is reached, wedges are locked in the place to hold the tension. This pre-stressing step is important to stabilize the structure and to transfer the load effectively to the ground. Move on to the next slide. After tensioning, the next step is corrosion protection and sealing. This is important to prevent damage from moisture or contaminants. For permanent anchors, we use a steel cap filled with grease or another protective material to seal the anchor head. This step to ensure the anchor lasts for a long time. For temporary anchors, a simpler method may be used since they are not meant to stay long. Protective is key to keeping the system reliable over the time. Move on to the next slide. Load testing and quality control. Before accepting the anchor system, we perform load testing. Each anchor goes through a pull-out test to make sure it can hold the expected load. Throughout the process, quality control is done by monitoring things like groove pressure, tendon alignment, and test result. If any issue are found, they are fixed immediately. This to ensure that the final structure is safe and meets the design standard. Finally, we have integration and surface finishing. Once an anchor passes the test, it is integrated into the structure, usually embedded into a concrete wall or face. Then, the area is cleaned and protected against environmental exposure. The surface is finished properly to give it a professional and safe appearance. All the important documents, such as testing results and installation records, are complete and stored as part of the project documentation.
The advantage is cost effectiveness. It is because ground anchors can be more economical than traditional methods like large gravity retaining structure, especially in situations where excavation is required for basement. The next one is adaptability. They can be installed in a wide range of ground conditions, including challenging terrains and geometry, making them suitable for diverse project sites. And reduce construction time, it is the advantage, and it is because the ground anchors can contribute to faster construction by allowing efficient excavation and reducing the need for extensive temporary works. And the last one is high load capacity. It is because they can handle significant loads, providing robust support for structure even in poor ground conditions.
Assalamualaikum and hi everyone. My name is Muhammad Naim Shukri. My student ID is 2023-801-258. Let's move into several disadvantages of using ground anchor. The first one is corrosion. Anchor rods are easily affected by corrosion, especially in soil with high moisture or acidity. This reduces their durability. And disadvantages is weak soil limitation. In soft or loose soil, ground anchor may not perform well unless supported by extra measure. Next is regular maintenance. Permanent anchor require routine checks and maintenance to ensure safety and function over time. The last disadvantage is groundwater issue. Constant groundwater can weaken the grout, so special mixture or method are needed to keep the anchor effective. In conclusion, ground anchor construction is a strong and reliable method for stabilizing soil and geotechnical projects. With proper steps like drilling, grouting, and tensioning, anchor offer long-term support. However, it is very important to maintain quality at every stage to ensure the safety and effectiveness of the anchoring system, whether it's for temporary or permanent use.